Okay, here's another lesson, 1-5, solving inequalities with one variable. Very straightforward. So here we go. Skylar competes in the high jump event at her school. She hopes to tie or break some records at her next meet. So notice this, her personal best, the best that she's ever done, she jumped at 1.48 meters. The district record is 1.57 meters, but the state record is 1.75 meters, okay? We need to write and solve an equation to find x, the number of meters that she must meet to add to her personal best to tie the district record. So let's think about this, okay? Her personal best right there, 1.48, okay? We want to add X amount of meters to reach the district record, which is 1.57. And our goal is still to get X by itself. When I subtract 1.48 from both sides, it's 0.09, voila. However, now we want to break it. So she wants to go higher than 1.57. So this means we're not going to write an equation anymore. We're going to write an inequality. That inequality is going to be greater than, okay? Because it needs to be higher than 1.57. So when we write this inequality out, let's do this in a different color. It's the same idea, but now it's going to be, instead of an equation, it's an inequality. Okay, so 1.48x plus, sorry, 1.48 plus x is greater now than 1.7, not equal to. It's not an equation. I still get x by itself. So x is going to be greater than 0.09. So that means it needs to be higher than 0.09 in order for her to break the record. Not tie it, but to break it, essentially. Okay, we're going to skip part C, okay, because our focus today in this lesson is about inequalities, solving inequalities when there's only one variable. And one thing I want you guys to notice is this, right? There's only one variable and you're still trying to get x by itself. Your goal, just get x by itself. And it does not matter where you choose to get x by itself. Notice in here, they chose x to be on the left, essentially, because all the x's are on the left side. One thing you also need to notice for when we solve inequalities is if I've got a negative on the bottom, when I divide by a negative, I got to flip the inequality. So notice here, when with all of these here, we were all greater. It became less than because now I'm dividing by -6. Because I'm dividing by a negative, I flip the inequality, essentially. Let's try this right here. We'll do this part B, okay? We can actually do it on this side. First thing I'm going to do is I'm going to distribute, okay? 8 minus 4x greater than 1, let's get x by itself. I subtract 8 from both sides, -4x greater than 7. And it's negative. My last step, let's divide by -4. Since I'm dividing by a negative, I have to flip the inequality. 2 negatives make a positive when I divide it, therefore x is greater than 7/4. It's that simple. It's not an equation though. There's no equal sign anywhere, okay? I'm not going to worry about graphing solutions. Just keep in mind this. It's basically, this is telling me any number that's less than 7/4 or 1.75, that those are the answers to that inequality. We're not going to focus on that. We're going to focus more about getting x by itself. Okay, so look at the next example here. Same exact idea when there's x on both sides. You guys get to choose where you want the x to be. And in this problem here, they chose x to be on the left side. Okay. So when they solve for x, they move all the x's on one side, all the numbers on the other side, and they got x by itself, okay? Same thing over here. Actually, let's do this one right here. Let's actually do this on here as a matter of fact, okay? 2x plus 5 less than 5x minus 22. Let's choose to move the x from right to left. So I'm going to subtract 5x. I get -3x. So -3x minus 5 is less than -22. I'm going to add 5 to both sides, so -3x less than -17. And then when I divide by a negative, I got to flip the inequality. 2 negatives make a positive. Voila, there you go. That is all there is to it, okay? Not much after that, okay? Focusing now on this, okay? Solving, again, inequalities, variables on both sides or what have you. If you notice this one here, 15 is greater than 9 when all the x's are gone in this particular case. This is always true. And if this inequality is always true, it's going to be infinite. Okay? However, if the inequality is not true, like this right here, this is a sad face because -6 is not bigger than negative 5? It's actually smaller. This is a no solution. Okay, it's a no solution case. Okay, so let's look at this example right here. We can actually do it on here. Let's look at part B. Okay, let's distribute the negative 3 first. Okay, negative 6x minus 5 less than negative 6x minus 3. I'm going to move the negative 6x to the right side or to the left side, but I get 0. So I got negative 5 less than negative 3. This is always true because negative 3 is bigger, so therefore it's infinite. Okay, all there is to it. That's all there is to it. Okay, your goal always is to still get x by itself irregardless. Okay, last one, and it's a word problem. Last example for this. Okay, Derek wants to order some roses online. For what number of roses is it less expensive from florist A compared to florist B? Okay, every rose in florist A is $4.75. So we'll call that 4.75x, but then there's a $40 delivery charge. For florist B, it's $5.15 for every rose, and x represents the number of roses, and then we need to add 25 for the delivery charge, okay? When is florist A smaller compared to florist B? Just solve for x after we put the inequality in between. Bam, okay? Get x by itself. X has to be greater than 37.5 roses. We'll round it up to 38. Essentially, okay? Focusing on the same one here. If florist B, though, increases to 520 a rose, but doesn't change the shipping, what is the comparison between the two sets of florists? Okay, so I know that florist A is 4.75x plus 40, but now we want less than, well, now it's 5.2x and then plus 25. And your goal, as I mentioned, is to get x by itself. Let's move 5.2 over here to the left side by subtracting it. If you don't know it, use good old Desmos for that ordeal. Let's pull up Desmos. 4.75 minus 5.2, voila, negative 0.45. Okay, so it's negative 0.45x plus 40 is less than 25. I'm going to subtract 40 on the right side. Negative 0.45x is less than negative 15. Okay, I'm going to divide both sides by negative 0.45. Okay, and if you don't know that, we can use Desmos again. Okay, so negative 15 divided by negative 0.45. There you go. It's 33.3 roses. So it's about 33, and we flip it, 33.3 roses when we round it up. Okay, that is all there is to it, kids. That is it. Okay, so your goal always is to get x by itself for solving inequalities. And as I mentioned here, if you divide by a negative, you're flipping the inequality. Always, always, always. So if you notice here in this part, the example, when there's a negative on the bottom, when we divide by a negative, you have to flip the inequality. Very important in the last step to get x by itself. Good luck in your 1-5 lesson.